Okay, so we've got this November 1957 Fender Tweed Harvard amp on the bench today. It's a 5F10 circuit, and I'm gonna just fire it up and check the voltages on the B+ line, the DC voltages. So we've got the amp out of the cabinet, and the amp is plugged into my dim bulb limiter. Dim bulb limiter is plugged into the variac. Variac is on, but set to 0 volts. And the amp is not turned on. I've got 2 ground clips attached to the chassis. One ground clip is for my multimeter, which we'll be using now. And one ground clip is for my signal generator, which I'm not going to be using just yet. So let's see what happens here. Now this amp has been modified by somebody in the past. You can see the 3 electrolytic capacitors there on the board. This should be the reservoir cap, and then 2 following filters. The spec on those is 16 microfarads, 450 volts, but you can see somebody has replaced them with 100 microfarad, 450 volt electrolytics. There's also a replacement coupling cap has been made here, and these Astron Minimites might be original, or they might be replacements stuffed back in the cardboard from the originals. I'm not quite sure, but the cardboard is loose on the caps, which makes me think that possibly these are stuffed with replacement electrolytics, 2525s. All right, but the biggest change here is this amp is a push-pull amp in class AB, about a 10-watt amp, and with a pair of 6V6 GT power output tubes running in push-pull, and then 12AX7 gain stage and phase inverter. It's a cathodion phase inverter, and then a 6AT6 input tube. 6AT6 looks a little fried here. It may, I'm not sure what's gonna happen there, but I have tested all these tubes on my Sencor Mighty Mite tube tester, and they all actually tested good. Now you can also see that the rectifier is missing. Should be a 5Y3 GT rectifier like this. But somebody has made a mod, and there's no tube rectification in this amp anymore, and that's the reason that they've upped the capacitance of these electrolytic filter caps. You can see that they've soldered in a 2-phase diode rectifier here directly on the pins of the 5Y3 socket. Right, and they've also added 2 additional reservoir caps, electrolytic reservoir caps. I can't see what the values are. The caps were added by gluing them in to the chassis with goop right here around the power transformer, you can see. Also, interestingly, you can see this Astron yellow cap. That is the death cap. It has not been removed. It's going right from the AC line on the fuse to ground. And I am planning to remove that. But right now I'm going to just test the amp in its in the condition it was when it came to me. So this is actually an electrocution hazard for players. You can also see that the power cord is not a grounded 3-prong safety cord like we have in modern appliances. It's just an old-fashioned 2-prong with no ground. So this amp is not grounded to earth right now, even though it is going through my limiter and the variac. The variac and the limiter are grounded, but the amp itself is not grounded. So it does present an electrocution hazard potentially if this cap were to fail short. Another interesting aspect of this amp is it has the original selenium rectifier in the bias circuit here. This is the bias circuit. Selenium rectifiers are prone to failure, and they can fail kind of catastrophically and release toxic gas when they do that. And even if they don't do that, they're prone to drift from spec pretty substantially over time. So I'm planning to replace the selenium rectifier here with a 1N5408 diode. Okay, so it's a nice little amp. You can see it's got this molded mica domino cap on the tone control here, between the tone control and the volume. And you can see it's got some of the original, apparently original, coupling capacitors. These are nice old yellow molded Astrons. And if these have not been stuffed, you can see we've got some nice little Astron mini mites, 25 microfarad, 25 volt. This is a capacitor bypass cap for the input tube, cathode, and it's parallel to the input tube resistor down in there. And this 2525 mini mite is part of the bias circuit. Should be providing negative 27 volts to the output section for bias. Okay, so I'm going to, the amp is plugged in, the variac is on, set to 0 volts. We've got our bulb limiter in, and I'm going to turn on the amp and then slowly dial up the variac. When I received the amplifier, when I opened it up, I did notice the number 47 pilot lamp was missing. And that's apparently because the lamp assembly, the holder for the lamp, the socket actually spins freely. And the way you install the lamp is by unscrewing the jewel here and pushing in the lamp and then twisting it so this little nub kind of connects and locks in. But I imagine what happened is, because this socket could spin freely, when whoever had this amp before me, before it got into my hands, tried installing the number 47 bulb, that the socket just spun as they were trying to twist the lamp in, so they couldn't get it to lock in. So I'll probably replace this lamp assembly. I've got another one right here. I've got a few to prevent the spinning, but I was able to, because I had the amp apart, I could just pop a new bulb in there. So hopefully that'll be lighting up as I turn up the voltage here. So let's turn up the voltage on the variac and observe the amp for any kinds of signs of smoke or other bad things happening. And we'll watch the tubes for the filaments to light up. And then I'm going to take some DC voltage readings with the multimeter. There are 2, 3, 4, 5, 6, 7 points on the board that I'm going to measure the B plus and the bias levels. Okay, well, let's crank up slowly, see if we can see. Any issues. When I get it up to about 100 volts, I'm going to stop. See if we can see. Let's see if I turn off the light. That might actually help. Let's see the red pilot lamp come on. So we're up at about 40 volts here on the Variac. And here comes the pilot light coming on at about 50 volts. Oh yeah, that's good news. And let's see how we're doing here on the Variac. Yeah, all right. Let's see. Just gonna crank it right up to about 100 volts, maybe 115. $117 was kind of the household standard back in 1957 when this amp was designed and built. It was actually built by Lilly in Fender's Fullerton factory. Lilly and Lupe were two of the most famous builders of these tweed amps. And you could tell that Lilly built it because she signed her name on this little piece of paper, little piece of tape there. Okay, well, so far so good. I'm going to turn the light back on now that we can see, so we can see a little better. And you can also see that the 5-volt filament lines for the rectifier have been removed from the socket for the rectifier tube and heat shrinked off. So even if you plugged a rectifier tube in there, nothing would happen, but because it wouldn't be powered when you're receiving its filament heater power. Okay, so do we have, let me turn this light off again here. We have filaments lit up on our Groove Tube 6v6. We have it on our Sylvania 6v6. We have it on our Amperex 12AX7 made in Holland. And we have it on our 6AT6. Okay, so everything looks good. It does smell a little warm. It's smelling pretty toasty. So, but amps do smell a little toasty occasionally. As long as we don't see any puff of smoke coming out of that selenium rectifier there. That would be a problem, because then I'd have a little bit of a health hazard on my hands. All right, so I've got the schematic here. I've labeled it. Well, this is actually a layout diagram. This is the schematic. And I've annotated that as well with my own names and numbers for each resistor and capacitor. But in pink, you can see along the board, I've labeled A through G. Those are test points where I should be seeing particular DC voltages. So we're going to test point A here, and there we go. 306 on the A node at 75 volts AC wall power. That is way too high. All right. So 75 gives me 306. All right. So this is the problem with this mod that somebody did, where they replaced the 5Y3 tube rectifier with a two-phase diode rectifier and added these additional electrolytic caps. I'm not going to plug this amp into the wall and play a guitar through it because it's absolutely going to sound horrible and it's going to be dangerous. Dangerous for a few reasons. One, the voltages are way too high, so any of these caps could just explode. Two, the death cap is still installed right there, that Astron. It's a cool little cap, but could electrocute the player if it failed short. And three, we've got this selenium rectifier in the bias circuit that if it failed would release toxic gases that would cause cancer or worse. So the good news is the tubes, filaments are all lighting up, and that's good. And also nothing blew, even though we were way over voltages here due to this solid state rectifier mess. So that'll be a little project. It's a beautiful little amp. The tweed is just old and decaying and falling apart, and it looks like it came from earlier than 1957, but it's got a cool vibe to it. So all right, that's our test of the B+ voltages. They're way too high, over 100 volts too high, and that's got to be fixed if this amp's going to be safe and sound good. All right, here we go.